Okay, so this is the problem we did in class twice, but it's the same as your homework except with different numbers. And you guys said you wanted me to make a recording, so here we go. So we start with this problem here. We start with 3 circles. Circle A is where you pedal. This is the pedal circle, or the pedal wheel. And then you see this red loop. That's the chain, the bicycle chain, that's pulling along on circle B over here. And then because circle B is pulling, it moves circle C. Circle B and C are on the same wheel, so they move with the same angular speed. So let's make a note here. So we know right now from the problem it gave us, we want to find the miles per hour of the bicycle when circle A is going around 1.3 revolutions per second. So one thing we know is that circle A and circle B match in a certain way, match arc length per second. And the reason why it does is this chain is making sure that those two have to match, because you see there's little teeth going all the way around, and it forces everything to be exactly the same speed. The speed at which this bicycle chain is forcing those 2 wheels, they're not going around at the same angular speed, but they're going around at the same arc length speed, okay? But the other thing that's matched is that circle B and circle C match in a different way. They match angular speed in radians per second. Okay, so there's 2 different kinds of matching, and so what we're going to do is we're going to set up a series of questions which allows us to pass the things that matter along until we find out what's actually going on. Okay, so I'm going to ask some questions, and it's the same questions you will ask, and your numbers will just be different. First thing I want to know is, what is the angles in circle A per second? I'm just going to write capital A, meaning circle A. How many angles do we have? And this is in radians. It will work if you do it in degrees. It will even work if your units are the whole entire circle. Okay, and if you're using like the whole entire circle as your units, then it's just still 1.3, but we're converting everything to radians. So the answer is 2 pi would be the full circle, all the angles in the circle, but times 1.3 because we're going around 1.3 revolutions per second. So now we have radians per second, okay? All right, so that's the first question. The second question you're going to ask is, what is the arc length in circle A per second? All right, and so we already have a formula, and this is why we converted everything to radians, because our formula assumes that we're using radians. We have the formula arc length is equal to r times theta, okay? And so since we already have, and we have, something's hidden in here, we're going to be using arc length per second is radius times theta per second. So the seconds are just kind of hiding in there. So we're going to still use the same formula. All right, so what we're going to do is we want to know the arc length, and the radius is 3, and the theta is just from the question above. There we go. And now we want to ask the third question. And that's arc length in circle B per second. Okay, and this time all we have to do, so let me color code these things. Here's the answer to this question. There we go. And here's the answer to this question. Maybe if I can highlight it. Okay, so what's great is because we have this match in circle A and circle B, they have to have the same arc length. So I just grab this answer directly out of here, and there we go. We've got it. Because they're matched. Okay, now we go to question 4. Trying to squeeze this all in on this little screen. Okay, question 4, we want to know the angle per second in circle B and C. And since it's the same, so we understand that they're matched, so I could have just made step 2 and 3 the same question, but I just broke it up. And step 4, I could have split it up into 2 steps the same way, but I think it's like, well, you're getting the picture now that there's things that are matching. Okay? And so I'm still going to do arc length is equal to radius times theta. Okay? And so now I'm looking for theta. All right? And the arc length I already had, so I have let's see. Arc length has to be over here, so I'm going to copy this guy. Because we said that's what it was, it matches. And then radius of circle B is 2, and theta